Welcome to the Y on Earth Community Podcast. I'm your host, Aaron Perry, and today we're visiting with climate scientist Julienne Stroeve. Hey, Julienne.
Hi, hey, Aaron. How are you?
Good. How you doing today?
I'm good, thanks.
So we're sitting here in the backyard of your home in Nederland, Colorado.
Yep.
One of my favorite places. And we're going to be talking about a part of the world that's quite far away from here, huh?
Yeah, it's very far away from here in a lot of ways.
Which is the Arctic. And we'll be talking about Julienne's work and research on climate and ice, and the impact she's seeing and the ways she's helping to communicate that science to folks and all around the world. So before we dive into the conversation, let me tell folks a little about you.
Okay.
So Dr. Julienne Stroeve received a PhD in geography from the University of Colorado in Boulder in 1996 for her work in understanding Greenland climate variability. Afterwards, she became a senior research scientist at the National Snow and Ice Data Center, NSIDC, within the Cooperative Institute for Research in Environmental Sciences at the University of Colorado Boulder. More recently, she was a professor at the University College London and recently was awarded a Canada Excellence Research Chair at the University of Manitoba. Her Arctic research interests are wide-ranging and include sea ice forecasting at seasonal, decadal, and longer-term timescales, climate change and impacts on native communities. She has participated in several field campaigns in Greenland and the Arctic Ocean. Efforts over the past decade have increasingly focused on trying to make sense of the rapid environmental changes being observed in the Arctic and what these changes will mean for the rest of the planet. Dr. Stroeve's work has been featured in numerous magazines and news reports, radio talk shows, and TV documentaries. She has given keynote addresses around the world on Arctic climate issues and has briefed former Vice President Al Gore and congressional staff. Dr. Stroeve has published more than 80 articles in peer-reviewed journals and has contributed to several national and international reports on climate change. She has been named by Reuters and Clarivate Analytics as one of the most highly cited researchers 5 years in a row. So
yeah.
That's a lot of research and publishing.
That is a lot of publishing, yes. Yeah, and it's a few high impact papers that really makes you on that list.
Uh-huh.
Yeah.
And I imagine some of these high impact papers are created through the collaboration of many, many scientists around the world. Is that right?
Definitely. I mean, when I spoke to Al Gore, it was in part because we had this paper in 2007 that we published, and it was the first look at how the observed Arctic sea ice loss that we're seeing, how that compares to climate models. And we were comparing that to the worst case scenarios from these climate models. So say we just do business as usual and we keep letting greenhouse gases accumulate in the atmosphere and don't do anything to slow that down, what would that look like in the future? And the paper was a bit surprising because we saw that the pace of ice loss that we were witnessing was faster than any of the climate models could capture. And so when we were looking at these dates for when the Arctic Ocean might become ice-free, the models were very conservative. And that was one of the interests that Al Gore had, was to talk about that, because obviously that means that this transition to a seasonally ice-free Arctic state will probably happen before the middle of the century. And we've had 2 publications since then, or actually more than 2, I think 4, on the topic using newer climate model output that go into like the IPCC reports. The models are still generally conservative in terms of their rate of ice loss, but even maybe more concerning is they're conservative in regards to the temperature sensitivity, so the amount of ice you lose per degree of global warming, or how much ice you lose per metric ton of CO2 you add to the atmosphere. And because of that, this is why we do think that we'll start seeing the first ice-free Arctic summers probably around 2040s time frame. And the models are definitely, they're getting better than they were from our 2007 paper. And the models are kind of now around 2050 on average for those first sort of instances of ice-free Arctic conditions. So we're on that trajectory. And this summer already, right now, we have the least amount of sea ice in the Arctic Ocean that we've seen at this time of year. So whether or not we'll hit a new overall record low at the end of the summer, so the least amount, at the end of the melt season, That's still unclear because it still depends somewhat on weather, but we're on track at the moment for another quite alarmingly low sea ice year.
And where are we, say, this year at this point in terms of percent of the average that we're accustomed to seeing over the last century?
I mean, the value that we have right now is less than any amount we saw in the 1970s or the 1980s or even the 1990s at this time of year. Well, not even at this time of year, for overall, like even in September, when you do hit the least amount of sea ice, we're about 6 million square kilometers of sea ice in the Arctic Ocean at the moment. And, you know, in the 1980s, 1990s, you tended to be around 7 or so. So it's already quite dramatic. And I think what, you know, we have this long-term change because of warming that's happening. But then, of course, you have fluctuations along that long-term change, right? So you have weather patterns that will maybe give you more or less ice loss in a particular year. I think we can't ever confidently say, well, this year is going to be a new record low for sure. What we can say is that we're not going to go back to conditions we saw 30, 40 years ago because we're in a new climate state.
Yeah. So you were up living in the Arctic with a number of other scientists and folks from November of last year, 2019, through April of this year, 2020, on the Mosaic Expedition. And I'm so curious because I haven't myself been up there. I've seen pictures and video, but what was it like being up there and spending so much time there through approximately half a year?
Yeah, I mean, so it's part of the German-led expedition where they froze their icebreaker into the ice for a full year. So in September, they left and they found an ice floe to decide that they were going to build a camp on. And they've just been letting the ship drift with that ice floe. And so the idea was that scientists, there's not one scientist that would be on the ship for a full year. So we each would take turns coming and going. And we were doing, 2-month rotations was the plan. That didn't happen quite like it was planned. We ended up there for 4.5 months. And part of the reason was the ship that was being used to do the exchange between our leg and the next people coming in to take over was not well equipped to deal with winter ice conditions. So it was very slow. In fact, it burned up almost all of its fuel trying to get to the German ship Polarstern.
Wow.
And so it wasn't able to refuel Polarstern. And we had to, when we did get on the ship to go back home, we were stuck in the ice for a month, basically on that Russian ship because we had to get refueled. They had to send another icebreaker to give us fuel so we could get home because we didn't have enough fuel to get home. It was actually quite an expedition. For me, what was really interesting was, well, one, it was the first time I've experienced polar night. So I had 3 months of darkness. Yeah. So we were working in complete darkness for 3 months. And temperatures were typically minus 30 to minus 40. So it's incredibly cold. Everything that you think you're going to get done, you think, oh, well, this will be an easy task. It won't take very long. Everything takes twice as long in the cold like that. A lot of the equipment that I brought, and I was pretty much responsible for instrumentation we put on the ice, which are similar to instruments that we have on satellites up in space. And the idea was to bring the same type of instrumentation on the ice floe so that we can look at things more on a smaller scale and better understand how snow and ice properties and atmospheric properties influence the retrievals that we get from satellite. Because when we use satellites to monitor changes that are happening on the planet, we don't actually measure the variable of interest. We're getting a signature coming back, whether it's emitted energy at certain wavelengths or reflected energy at different wavelengths, and you then have to convert that into something meaningful. But that really depends on how that energy interacts with the medium that it's going through, so how it interacts with the snow or the ice. So we had a full suite of instruments that we put on the ice that were very similar to what's up in space. And it was the first time we had sort of a full suite of active and passive microwave instruments. So these are instruments that are either measuring the amount of energy emitted in the microwave portion of the electromagnetic spectrum, or we send a pulse of radar down and then we measure its backscatter. And we had data from like 0.5 gigahertz all the way to 89 gigahertz, which probably doesn't mean much, but the one of the reasons why microwave is so useful for monitoring places like the polar regions is that it can see through the clouds. And it doesn't matter if it's polar night or not. So you're still going to see the surface, which is a problem if you're using visible data, for example, or even thermal infrared data if you have cloud cover. So then you can't see the surface. So But we, because it was quite cold and it was dark, we had a lot of equipment failures.
Yeah.
So I think we spent most of our time repairing cables that would just break in the cold.
Wow.
Just instrument parts they just kept breaking. I think I spent most of my time troubleshooting instruments.
Yeah.
But I did get some good data collected. I've already submitted my first paper, just sort of highlighting what the radar that I brought specifically for the expedition could do. It was a $600,000 radar that I had built by ProSensing in the US, and it's sort of a prototype because it measured at 2 different frequencies, which are used for measuring sea ice thickness, and maybe in combination could also back out how much snow is on the ice. And at the moment, the European Space Agency is considering building a satellite with those same frequencies on it. So the data I collected is very useful to decide whether or not this data could really inform us and help us simultaneously retrieve both how thick the ice is and how much snow is on the ice. So that was my goal on Mosaic while I was there.
Oh, very interesting.
Yeah.
So how many other people were you with up there?
I think we had between 80, 90 or so people on board, and that was a mix of scientists and crew.
Yeah.
And, it was really, we had such a great group of people, and I think you always really get bonded to people on an expedition because you can't go anywhere.
Yeah.
You're forced to hang out with each other, so you might be working together, but then in your evenings, there is no internet. You can't go check out. So you hang out, you play games, you talk to each other. We would have bar night 3 nights a week. We'd play cards. Yeah, it was just, we had a lot of fun together. And there was a gym and a sauna, so we also would all go use the sauna together. And
nice, yeah.
yeah, so you really get to know people quite quickly and close in such an environment. So I know for me and everybody I've talked to that came off the expedition with me, none of us wanted to be home because even when you're on a ship like that, the things that you might miss, the kinds of food you might miss that you don't get to eat, or going to a cafe or going to a bar and things like that, we couldn't do them when we came home because of COVID.
Right.
So we went from this environment, this very social environment where we're playing and working with like 80 people to like complete lockdown.
Isolation, yeah.
And you're just like, you're already depressed when you get off of an expedition, I think. Just because you miss the people, you miss the experience. And then to have that on top of COVID was just like, oh, I think I was depressed for at least a month.
Oh my
sure.
gosh, yeah.
Yeah.
I can believe that.
Couldn't really get much work done. I was just not motivated. Yeah.
Did you come directly back to the United States?
No, so my residence is in London.
Yeah.
So I went back to London first. We were chartered. So our ship was able to dock in Norway, and then the Germans chartered an airplane for us to fly home to our respective countries.
Yeah.
And I went back to the UK, and then I didn't get to see any friends because everybody was really taking the lockdown seriously. And I think being on a ship, you didn't realize maybe how serious it was because we were detached from it all.
Right.
And, all of us were healthy because we left for the Arctic before COVID had come about. So we were all like, wait, we don't want to leave the ship. We could just stay in the Arctic. It's the best place for us to be right now. It's healthiest.
Yes.
Yeah.
So I imagine it was rather surreal when you guys started to hear about COVID.
Yeah, first we would just get these international news clips every day that the Germans would kind of download for us. And, I'd see the stuff out of China and that China was locked down. And then we started seeing things emerging in Italy.
Yeah.
I thought, okay, but I still thought it was going to be more isolated. I didn't expect it to spread quite like it has and get as bad as it has.
Yeah.
But again, I was not seeing any news. I wasn't reading or seeing any TV or anything like that. So I didn't get the sensationalism.
Yeah.
We just kind of got these little facts, statements about how many people or, what was going on. So yeah, it was interesting.
Yeah, I imagine.
Yeah.
Well, I know that you and I have first crossed paths, many years ago, in fact, because we both at that time resided in the Boulder, Netherlands area.
Yeah.
Turns out we have 2 kids each of similar ages.
Yeah.
And you're younger. Your son is the same exact age to the day as my daughter, my oldest.
Right.
And we've also kept in touch around climate and have a number of colleagues and organizations in common that we collaborate with in various ways. And I've always been struck, Julian, that you not only are conducting science, but you're also speaking to the general public as well as to officials and policymakers around the data and the potential impacts that you're seeing and possibly even at times recommendations. And I've been struck that over the years I've noticed that sometimes there's an emotional impact when it sounds like or seems like so many people out there dismiss science, think it's false, think it's, fake news or what have you. And I'm curious if you might share with us a little kind of behind the scenes, behind the papers, behind the formal and official presentations. How does that make you feel as a person attempting to help the world?
Well, I would say that this idea that it's fake news or it's not true seems to be largely limited to the US.
Yeah.
When I would get on airplanes, traveling for business or whatever, and I would sit next to somebody on an airplane. If I was in the US or sitting next to somebody from the US, they would always ask me if I believed it. Just like, okay. Whereas in Europe, if I were to have a similar question, told somebody what I did, they would be like, is it as bad as we think? Yeah. Is it worse? Yeah. So it's a really interesting thing because in Europe, there's not this sense that this is fake and it's not happening.
Yeah.
They're much more on board about it, and they understand that there's going to be some serious implications of this climate shift that we're going through. And it is frustrating to me, I think, in this country. And I did play around for a little while blogging with some climate skeptics because they were really targeting the Arctic sea ice because that had become our poster child for climate change. Mm-hmm. And the reason I went into studying the Arctic regions is because, or just polar regions in general, is because, snow and ice is a really great balancer for the climate on our planet, right? So it reflects most of the sun's energy back out to space. So if you start reducing the amount of snow and ice on the planet, then the land surface or the oceans will start absorbing that heat. Yeah. And so, it was kind of like if we were going to see climate change happening, we would first see it in the polar regions. And then it would become this positive feedback where, you melt more ice and then the land absorbs more of the ocean absorbs more heat and then that melts more snow and ice.
Yeah.
So you're in this vicious cycle with
not positive in the good sense,
right? Not positive in the good sense.
Just reinforcing, self-reinforcing.
Yeah, and so that's why I started studying it. And when I went into it, I didn't think climate change was happening. When I was working on my PhD, I went to Greenland in 1993. It was quite a cold year. There was, it's after the Pinatubo eruption, so that cooled the climate for about a year anyways. And I just, the data wasn't really showing that there was this anthropogenic signal quite yet. Yep. But that really changed in the 2000s when we just kept having one record low sea ice year in a row in the Arctic that couldn't be neatly explained by sort of the atmospheric circulation patterns. And then when 2007 happened and you lost 26% of the summer ice within a single year compared to the year before.
How much?
26%.
Wow.
And it took everybody by surprise. Nobody expected that to happen. And what we hadn't realized was that while the area had been shrinking, the ice had gotten a lot thinner. And that's just data we don't have a lot of information on. So we haven't had these really long time series of how thick the ice is. We've had over 40 years of observations that tell us how much of the ocean is covered by ice, but not how thick that ice is. And so what's been happening is if you do have an unusual atmospheric weather pattern that sets up in the summer, you can melt out a lot more ice and you can have a lot more open water now than you used to, just because the ice has gotten so thin and vulnerable. So I did talk to skeptics for a while because they would target the sea ice record and they were trying to make it sound like maybe the record's not accurate or it's biased. And there's a lot of effort that goes into making sure these data records are consistent across different satellite programs because we don't want to bias. I don't want to bias my science by not making sure that the instruments are not well calibrated to each other to make sure that the data record is consistent over time.
Yep.
And I think as a scientist, you just think, well, okay, I know how I'm processing the data. I know what's going into this. I trust my data record that I'm getting. And then how can you not just see, okay, well, you see the steep decline. Don't you understand what's happening? And why are you trying to dispute that it's happening?
Right.
So I found that there were two sort of trains of thought that you would engage with in these climate skeptic world. One would just be outright deniers, and they don't care what data you show them. They're only going to cherry pick the data that tells the story that they want. And they'll ignore all other scientific evidence completely ignore it. Then there are, skeptics who actually will ask you questions, and they will try to better understand how the data is being produced and the feedbacks and things that are controlling it. But after a while, I just got really frustrated. And I noticed, so I did some tests too, just because I was just curious how people would respond if I said the same thing under a pseudonym name versus my name. And when I used my name, people were very careful to not attack me personally.
Okay.
But if I said the exact same thing under some alias name, they would just attack the person on a personal level. And I thought that was really fascinating. And I just realized that, these people weren't really worth my effort anymore to engage with. If somebody is interested in having a conversation and really want to talk about the data and the analysis that I do, I'm happy to do that. But it's just, it got very frustrating.
Imagine.
Yeah.
So I want to throw in a couple technical terms because I can make my inner nerd a little happy. So this reflective property of snow and ice is albedo, right? This is the albedo effect. Is that?
Yeah, we call it the ice albedo feedback.
Okay.
Basically. So, new snow has an albedo of around 0.85 typically. So it reflects 85% of the incoming solar radiation back out to space. Now, once the snow melts off and you have bare ice, that albedo will drop to about 0.6. So then bare ice areas can start absorbing more of the sun's energy. Oceans have a very low albedo of like 0.05 or something. So they absorb a lot of heat. And this is why we have this amplified warming in part in the Arctic, is because we've been losing the summer ice, the oceans now in the Arctic has been absorbing that sun's energy. And it's getting stored in the mixed layer of the ocean, which is usually about 50 meters deep. Mm-hmm. And so before the ocean can freeze again in the wintertime, all that heat that it gained over summer has to be released back to the atmosphere. So when we look at these things and say, okay, well, we want to limit our warming to 2 degrees, well, in the Arctic, that means like 9 degrees in the autumn and winter season because of this amplified warming from the ice albedo feedback and the ocean now putting a lot of heat back out before it forms ice again. So the warming that you get in the Arctic is more than twice what you get for the planet as a whole. And this would have all kinds of implications. Not just for the ocean and all the marine ecosystem that is dependent on the sea ice, but also coastal communities, because obviously now with the ice being so far north, they're now exposed to waves from storms when a storm comes in, and you've got the coastal erosion, you've got the warming now that's thawing the permafrost and making these coastlines unstable. And of course, there's a lot of methane in that permafrost. So this amplified warming of the Arctic is sort of this, it's kind of a scary thing, because when you start releasing more of that carbon that's stored in the permafrost, there's more carbon in the permafrost than there is in our atmosphere today. So that's a big feedback. And then, of course, you got the Greenland ice sheet. So if you warm up the Arctic more and you melt more of Greenland, you've got 7 to 8 meters of global sea level rise contained in the ice that's on top of that ice, on top of Greenland. So I think, if I were to say what concerns me most about climate change, maybe the Arctic Ocean isn't a concern to people at lower latitudes because they think, well, that's so far removed from me. And maybe people will feel sad about polar bears dying. But again, they're kind of removed. But it's sea level rise, which I think will affect, we know it's going to affect billions of people around the planet. And it's also changes in precipitation patterns, because everything that goes on in our climate system on this planet is interconnected. And so the temperature difference between the equator and the poles drives most of our large-scale atmospheric weather and ocean circulation. So by warming up the Arctic so much faster than the rest of the planet, you're changing your jet stream patterns. And that means you're changing your precipitation patterns. And that also will change your ability to grow food and where you can grow food.
Yeah.
So, and for me, I just think of it as this big social justice thing, because obviously we in the Western world have created most of this. And yet we will probably find a way to be okay for the most part, whereas the developing nations are the ones that are going to suffer the most. And as we already see with, COVID, or even what happened in Syria, nobody wants to take in refugees. Yeah. And what are we going to do with all these people that will be displaced because of climate change?
Right.
We just let them die?
Right.
So I have a hard time with that.
I have found it really interesting over the years that not only has the science community worldwide seen with relative clarity these massive systemic risks. The military and the intelligence communities have also been looking at this because they have to concern themselves with things like millions of people being displaced.
Yeah.
And I know, speaking with some folks who worked in intelligence and or military over the last several years, it struck me that these folks all around the globe, including especially here in the United States and of course in Europe, are looking at scenarios where we have 10 times as many refugees as we have currently in the not too distant future. And I don't bring this up to be alarmist or little what is it, Chicken Little, the sky's falling, but this is real life stuff.
It is real life stuff. And so I don't know if people are all aware, but the CIA had a task force on climate change. And they used to come to NSIDC when I was working there to get briefings from us, because they were really concerned about the Arctic, the geopolitical situation in the Arctic, of course, as well with Russia. But and they're also very concerned, of course, with the Middle East and the Himalayas and the water resources in that region and the political instability that results from the lack of water in those regions. And so they are very concerned about climate change, even if, our leadership right now doesn't care about it.
Right. And has that task force stayed active during the current administration?
That I don't know, because I've been in the UK since the current administration. So I haven't met with the CIA task force since I've lived in the UK.
Yeah. Okay.
So I'm not sure.
Yeah.
Yeah.
Well, it's a lot. We're dealing with obviously very complex systems affecting all of us in different ways.
Well, and I think that's the important thing that I think people should remember is it's not that one part of the planet can change in isolation of the rest of the planet. Yeah. Everything's connected. And so we're creating an instability in a part of the world. And I was at a conference last August in DC that brought together a lot of indigenous peoples to talk with scientists and really just raise the alarmism. I was really surprised at some of the talks that these people gave about, how their lives are being affected by climate change in the Arctic. There was one woman that told a story of she lost her sister and her brother-in-law because and I think the child, because their ski-doo went through the ice, because the ice was too thin and it wasn't stable. Yeah. And for them, they say they've lived in the Arctic since time immemorial. So, which means, I don't know how long, maybe at least 6,000 years or longer. And they have adapted to this really harsh environment. But they really understand weather and ice. They have, so many more different words for snow and ice than we could ever imagine having. But they're traditional indicators of when they think conditions are safe to go out or, what the weather's going to do. They're not working anymore because the climate's changing so fast. And so that's really affecting their livelihoods, and they are suffering huge losses. But that's not a story that gets told,
Yeah. Speaking, Julian, of stories getting told, I want to make sure folks know about some of the resources that you've been a part of creating, where they can find more information, see images and videos. And it includes the website for the National Snow and Ice Data Center, NSIDC.org. All of these links and resources will be listed in the show notes as well. And then the University of Manitoba has a resource, CEOS, CEOS. It's umanitoba.ca/CEOS. Can you tell us a bit about what's on that resource?
Well, it's a Center for Earth Observation and Modeling. So that's where I have a new Canada 150 chair. So my program there is really focused on understanding the links between sea ice and atmosphere. So not just in terms of what drives sea ice variability, but also how the sea ice variability will influence the atmosphere. And so one of the things we're looking at right now, for example, is how ice loss will change precipitation just within the Arctic itself, and whether that precipitation will fall as snow or as rain. And in particular, I've been really interested in how, if we have less winter ice and you have this open water, you have this moisture source for storms already. But then if that storm were to drop that precipitation as rain, then it'll still refreeze in the wintertime. But when that happens, you get this ice layer on the snow. And then the reindeer or the caribou or the muskox, they can't break through that ice layer to forage for food in the wintertime, so they starve. And so there's sometimes these massive die-offs where you have like 30,000 caribou die in one winter because they're starved to death. And so I'm trying to better understand how these frequency of these rain on snow events in winter may change. So we can do a better job trying to do, management of these herbivores.
Wow. I'm just making a note here on that point. And then let's see, you also have a Twitter feed at Julienne Stroeve, and you're on Facebook, Julienne.Stroeve. And through those, I've seen in the past several months a number of your photos and other discussion of your recent time in the Arctic. And am I recalling correctly, I saw something about some sort of animal approaching one of your equipment stations.
Yeah, it was actually, so every time we were on the ice, we had to have a polar bear guard with us, right?
Okay.
But it was polar night, so being a polar bear guard is very challenging because you can't see it, it's dark, and it's very cold, so people would do like 2-hour rotations in being a polar bear guard. But we hadn't seen a bear, and we had this bonfire that night, actually, so out on the ice. Sometimes we'd just burn wood and sit outside and drink mulled wine or something, just to get out of the ship. And so we had a big party, and then later that night, a bear came to our remote sensing instruments and just moved one of the antennas into a different direction and kind of ripped off a little bit of the cover. But it was actually very remarkable that he actually stepped over all of the cables. I mean, I had probably about 20 some plus cables going from a power hut where, the power source was coming in, and then we were feeding it to all the instruments. So it was network cables, it was power cables, things like that, to all the instrumentation we had on the ice. And he didn't rip any of them out, which I couldn't believe. You could see that he stepped over all of our strings of cables that we had. And the only reason we saw him was because we kept a surveillance camera on the hut that would go off every 5 minutes to just monitor the stability of the site, because we didn't want, like if a storm were to come and the ice were to diverge and a lead open up, we didn't want to lose our instruments into the water.
Right.
And so it's one way to keep things monitored about what's happening with the ice. But we just noticed the next morning, that one of the instruments wasn't looking the right way. And we're like, well, that's odd. And then we flipped through the surveillance camera footage and found the bear.
Oh my gosh.
Yeah.
Wow.
Yeah. I mean, he actually didn't do that much damage. I was able to re-rotate the antenna, so that wasn't a problem. A polar fox was more damaging. It ate up 3 of my cables.
Oh, interesting.
Yeah. So then the people from Met City, which is all the meteorological measurements, they started putting gasoline on all their cables. We didn't do that, but the fox actually didn't come back. We just tried to make sure there was nothing on the ground that fox could get. Yeah.
Wow.
Because the fox,
oh my gosh.
Yeah, I guess they like to chew cables, and that could be quite dangerous if they went through a power cable.
Sure.
Luckily, it was mostly network cables that he chewed up.
Wow. I've heard of rodents going after cables, but I didn't know foxes did that.
Yeah. Well, and because we saw a fox, it probably meant there was a bear around somewhere. Because we've been told that the foxes tend to follow the bears and they just scavenge.
Okay.
Because, there's nothing out there in the middle of winter. There's absolutely nothing.
Yeah.
There was one day I was sitting, 2 days a week I would spend time in this ROV tent, and it was a tent that we had over a hole in the ice where we would lower a robotic vehicle that would do different things. So sometimes we would scan the underside of the ice to look at, the surface or the bottom topography of the ice. Sometimes we would trawl nets behind us to try to see what are we catching, how much zooplankton is in the water, is there any fish? We had sediment traps. And one time I was sitting there just waiting for the vehicle to come back up, and I was talking to one of the polar bear guards, and a seal popped its head
Oh my gosh.
out of the hole. We're like, oh my God, there's a seal. And this is, the middle of Arctic winter. And I didn't see any fish. Like, I don't know what he's eating, but he was hanging out and getting air in our hole. And yeah.
Oh, what a treat.
That was pretty cool.
That must have been a lot of fun to see.
Yeah.
Wow. Let me just really quick give a shout out to some of our sponsors who make this podcast episode, along with the rest of our Why on Earth podcast series, possible. And that includes Alpine Botanicals, the Lidge Family Foundation, Purium, Vera Herbals, Growing Spaces, Soil Works, Earth Water Press, 1% for the Planet, Dr. Bronner's, and Waylay Waters. And by the way, with Waylay Waters, they are making those CBD aromatherapy soaking salts available for monthly shipment to folks who join the monthly giving program at certain levels. So a big shout out to everyone in the monthly giving program. And if you haven't yet joined and you'd like to, you can go to whyonearth.org/Waylay-Waters to find out more about that. A huge thanks to everyone making this podcast series possible, our discussion today with Julienne possible, and also our community mobilization work possible, working with folks all around the country, the continent, the planet for climate action, soil regeneration, neighborhood resilience, health and wellness, and culture of kindness, which is clearly very important right now. So I know, Julienne, that a lot of the work I'm doing and a lot of the folks in the Wine Earth community are doing is helping to inspire people to make lifestyle changes, to do sometimes simple things like composting and changing up eating habits, travel patterns, whatever it might be.
Mm-hmm.
And I want to ask you a question that I know you and I have spoken about before in the past, and it's not always my favorite question to ask, and it's not an easy one to discuss, but given what you see through the science and the data, how hopeful or not, how pessimistic do you end up feeling, and how does that affect you as a mother, as a parent with young children, in the earliest years of their adulthoods?
Yeah, usually when I speak to people, I try not to be so pessimistic. Only because I know that we can change it. So I guess that's, like if we were to lose all the sea ice in the Arctic Ocean, it can come back. It's not irreversible. So I think in that regard right there, there's hope that if we were to change how much, CO2 we keep putting in the atmosphere, things like that, it would make a difference. Yeah. Whether or not we do it in time, I don't know if we will, and that concerns me. And, I think the thing with COVID that's been really interesting is it shows us how quickly people can change their way of life.
Yes.
It's so fast, just like that. We can change how much we travel, how we interact, and so we can make these changes also to our planet for its well-being. And I think, being in London was very interesting during COVID because it was the first time I ever saw the city have absolute clean air, because there's no cars really on the road. And now they're going to invest like 12 million into bike lanes and encouraging people to bike, because everybody started biking. I mean, you could bike into central London from where I live out west, and it was an enjoyable ride. It was wonderful, and you didn't have to deal with a lot of cars. So
yeah,
I think people started realizing that, well, hang on, we kind of like this change of pace and being more physically active by using our bicycles instead of getting in our cars. I noticed, people were hanging out with each other, and everybody was picnicking in the parks and being outside, and it's like, actually, that's really nice. I saw 2 seals come up in the Thames. I was like, wow, there's seals in the Thames. And so it's very quickly that we can adapt our behaviors and our lifestyles if we desire to do so. But we're not thinking that climate change is like COVID. You're not thinking you're going to die this year. And maybe that's the harder part with humans, is like, this is something that's coming along slowly, but it could become quite drastic by the end of this century. And my biggest concerns really are Greenland and Antarctica. And Antarctica, we thought, oh, well, it's not going to respond for a really long time because it's so much colder than the Arctic region. And so even if you were to warm up by 5 degrees, it's still well below zero. But what they've been finding is there's a lot of instability now in some of these floating ice shelves. And part of it has to do with warming ocean waters that is eroding these ice shelves. And it's like, the Antarctic has a lot of these floating ice shelves that they're part of the glacier, but they're floating on the ocean. When you break them off, they're already still floating on the ocean. So that doesn't raise sea level rise, but it's like a dam breaking, and they're holding back all of that glacier mass that's behind it. And then that can accelerate. And so right now, Greenland's already been contributing 1 millimeter, maybe a little bit more now per year to global sea level rise.
Wow.
Now the Antarctic is as well. And it hadn't been. And the Antarctic has a lot of ice. like 80 meters of sea level rise contained within that continent. So I think we don't fully understand how quickly these systems will respond. I think when I went in as a PhD studying Greenland, I didn't think you're going to see any massive changes in Greenland, but already Greenland has been melting quite a bit and contributing more now than ocean expansion or other glaciers to sea level rise.
What's the potential of Greenland's ice? You said Antarctic's is 80 meters?
Yeah, Greenland is 7 to 8 meters.
7 to 8.
So it's 10 times.
Wow.
I mean, that wouldn't happen probably in our lifetimes, but
Yeah.
this is why our forecasts for what kind of sea level rise we're looking at the end of a century have such large uncertainties, because it can be anywhere from 1 meter to 3 or 4 meters. We don't know.
And the majority of the human population lives
Within 30 miles of the coast.
At or near sea level, yeah.
Yeah.
So that's a huge impact.
It's a huge impact.
Yeah.
Yeah.
Can you just walk through in concise form the difference between why terrestrial ice leads to sea level rise and why ocean ice doesn't? I just want to make sure folks understand.
Yeah.
That.
Well, ocean ice is like an ice cube in a glass of water.
Yeah.
So when it melts, it's already displacing the water level anyways when it's floating. So it's not going to change it much when it melts.
Yeah.
Whereas the land ice is on land, it hasn't been in the ocean yet. So once it goes in, that's where the sea level rise comes from.
And Greenland has been melting at extraordinary rates, right?
Yeah, before I think it was roughly in balance between how much surface was melting and how much was being discharged through the glaciers from icebergs. But now the surface melting is contributing much more to sea level rise than the glacier discharge. And so you're getting a lot of runoff from Greenland. And I know the latest climate model output from the next that goes into the next IPCC report, under the same radiative forcing at the end of the century as we had in the last report, the melting over Greenland has doubled for some reason. So, and I don't know if they're just improving some of their modeling capabilities, but it's almost double what we had last time. So maybe our estimates even on what we think Greenland will contribute has been underestimated.
Yeah. And IPCC is the International Panel for Climate Change.
Yeah.
So this is a consortium of scientists from around the world, yes?
Yeah, so they come together and they try to synthesize all the publications and all the science understanding that we have about the climate system. So you have different people working in different areas. And there was this special cryospheric report that came out, was it last year or the year before? Just a kind of a special state of the cryosphere and oceans report that the IPCC did. And I wrote one of the chapters about the sea ice and Arctic amplification for that report. So that was trying to summarize, our current understanding of how dire the cryospheric changes are.
And cryosphere means frozen?
Cryosphere is just all those places on the planet that are frozen water in some form. So whether it's snow or permafrost or glaciers and ice sheets, sea ice.
Yep.
That's the cryosphere.
Great. This is so great to be able to talk with you, Julian, and I'm grateful that you've taken the time to visit with me and share with the Y on Earth community today. And I'm just curious, before we sign off, if there's anything else you'd like to share or say, and in particular, if you could, provide any sort of recommendation or even, we might say, advice to us here in the general public, what might that be?
I mean, I think we each have to sort of start thinking about what can we do individually, for sure. I mean, I was flying a lot. So as a climate scientist, I flew a lot to meetings all over the world, all the time. I feel like I was traveling maybe twice a month. I haven't traveled since I got off the ship, except now to come back to Colorado for a bit. So all of our meetings have gone online and virtually. And I think we're going to take advantage of this for a while. I think that, it's been so nice not constantly getting on an airplane and traveling to meetings. I mean, face-to-face meetings are still really nice, but we don't always have to do it.
Yes.
And we can do more virtual meetings. And that right there has a huge climate impact by not flying so much. Even just in my daily life, I've become very conscious about my waste. And in London, there's this fantastic bulk food store that's near my tube station. And I can get everything I need except my produce there. And I just bring my containers and I fill up. And I've reduced my waste dramatically. I don't do plastic waste anymore. I don't have cans. It's just been really nice to think about it that way. And I think if we just all start individually thinking about what can we do on our just small scale. And then, of course, we need to get the leadership that will put these programs in place on a larger scale.
Absolutely.
And so...
And decarbonizing energy is critical, right? And right now the leadership in this country, the United States, is absolutely 180 degrees from where we need to be on that issue.
Yeah, and there's not one single energy that's going to meet our needs. I think what we've realized now is there's not an energy solution at this point that, well, one, has no climate impact whatsoever,
right,
because everything does. And two, I mean, it's really that we have to start reducing our consumption. I mean, that is really what's needed. And we're going to have to start sucking carbon out of the atmosphere. If we want to get to the below 2 degree target, because, I mean, right now the Arctic sea ice kind of disappears at 1.7 degrees. So that's before the 2 degree target. And
that's 2 degrees Celsius, right?
Yeah, 2 degrees Celsius for global warming. And basically the only way to get there now at this point is going to be through carbon capture. We're not going to be able to do it quick enough with energy. I mean, unless, what if we all just stopped traveling for a while?
Well, and I know a lot of my
we're all locked down for a while.
Personal friends and colleagues are very enthusiastic and focused on the soil regeneration capabilities for carbon sequestration.
Yeah.
And the numbers we're seeing are a 10% increase in terrestrial soil carbon is equivalent to sequestering all the fossil carbon we've released since the beginning of the Industrial Revolution.
Wow.
Going from 280 parts per million to over 400 parts per million.
Mm-hmm.
So it's not necessarily easy, right? It's going to take a whole lot of concerted effort at every scale.
Right.
But one of the things I love about the carbon sequestration with soil is that it's also something we can each do in our own homes with composting and soil building strategies, our own neighborhoods.
Right.
It's the kind of thing regular folks can be a part of.
And I think that's what we just need to provide, maybe better guidance on how everybody individually can do things that will help.
Yeah.
And then scale it up to your community and to your state, and
Yeah. The Y on Earth community is working on a set of resources for this very thing that we'll have out, we think, early in 2021. So it's absolutely right. And there really is so much we can do. But you hit the nail on the head. It's about getting the right information and inspiration to folks in a way that's very easy to understand and then adopt, basically.
Yeah, and I guess I have this hope that COVID has shown people that they can change their lifestyles. Yeah. And I'm hoping that for some people they really enjoyed the change. Mm. I think in the UK, especially in London, being in such a big city, I think people really loved that there wasn't all this car pollution anymore. That the air was clean and nice, and there weren't all these cars on the road. It wasn't so noisy. It was just really much more peaceful. Yeah. I didn't have airplanes flying overhead. Yeah. For 2 months. I was like, wow, there's no airplanes overhead. And normally I have constant stream of airplanes. Yeah. So, I don't know. I guess the
livability is better in a lot of respects.
Oh, so much better.
Yeah.
So much nicer. Yeah.
I've even noticed around here in places like Boulder and Denver that the birds seem to be more happy. Yeah. They seem to be singing more.
I believe it. Yeah,
and I think it's a great note to end on, perhaps, that a lot of these changes that we probably need to be thinking about making and choosing to make often imply better quality of life, not worse.
Exactly.
And to me, that's a very hopeful message.
I mean, for me, one of the simplest things that I absolutely love is I have this farmer's market by my house on Sundays, and I go to my farmer and I get my milk in a glass bottle. Yeah. And it makes me really happy to have a glass bottle, and then I bring it back and I get another one, and it's so great. I love that. And he's got only, grass-fed cows, so all their milk is really good, and it's just really
good for the carbon cycling too when it's grass-fed.
Yeah. So, and I mean, we kind of got away from all that. I mean, everything was disposable. Yes. But I don't know, how much nicer is it to have things in a glass container versus plastic? To me, it's not. It's a lot nicer.
Yeah, I agree. I really agree. Well, this is so great, Julienne. Thanks so much for chatting.
Yeah, thanks. It was really fun.
Great.
Yeah.
Talk to you later.
Okay.
Bye, everybody.
Bye.
The Y on Earth Community Stewardship and Sustainability podcast series is hosted by Aaron William Perry, author, thought leader, and executive consultant. The podcast and video recordings are made possible by the generous support of people like you. To sign up as a daily, weekly, or monthly supporter, please visit yonearth.org/support. Support packages start at just $1 per month. The podcast series is also sponsored by several corporate and organization sponsors. You can get discounts on their products and services using the code YONEARTH, all one word with a Y. These sponsors are listed on the whyonearth.org/support page. If you found this particular podcast episode especially insightful, informative, or inspiring, please pass it on and share it with a friend whom you think will also enjoy it. Thank you for tuning in. Thank you for your support. And thank you for being a part of the Y on Earth community.